So, you know what, actually. Brief summary of recent events / announcements moving forward. So last week, even remotely, I gave out information for they sent me assignment 5. I realized after printing it, it said assignment 7 on it. I apologize. But all the information for assignment 5 has been given out. But since we haven't met in person recently, I want you to spend as much of today as you guys need going over specific questions from it, working some examples. I do have the next assignment ready for you guys, depending on how long it takes us to close out. This current assignment will depend back when this one is due. Let me check something real quick. Okay. So, a brief summary list of things to come. Firstly, this week, normal class meetings, work as normal. Next week, that is the end of March, beginning of April, and a very nice email went out that the school is planning on canceling class on 2 more days than usual to give everyone some rest days, which I think is sorely needed because we all need a vacation from the past year, 2 years. So one of those days that was canceled was Friday, April 2nd, which would be the second of our 2 meetings next week. So that means completely no class this particular day, and the assignment due dates will be adjusted accordingly. The week after that is that normal? Do we have 9th off? Oh, hold up. The reason this day is off is because this is Easter weekend, thank you. So we, by default, have the Monday off as well, I think, which doesn't affect this class, but do please enjoy a nice 4-day weekend. This class will proceed normally next week.
Our exam is that Wednesday.
Sorry?
Our exam is that Wednesday.
Thank you for asking. It won't be. I did originally say that there was, test 2 was going to happen around here. No. This is like, I'm hopefully about to give you the second assignment after the last test. So I want to get some more work in before that test happens. Additionally, yeah, we wouldn't meet that Friday, so I wouldn't want to give you a test like first thing after not seeing you for a week. So at the very least, I see that being moved closer to the middle or end of April. If I had to go ahead and put a number on it, I'd say the 21st would be. It is? Well, thank you for telling me.
Which days on
The 21st.
So definitely not the 21st. Maybe the 20.
The 23rd.
I'm very glad for these rest days. I honestly think everyone needs them. But boy howdy, I do now have to go through slightly more hoops to plan things. I'll do that work, because I think we need these days. You guys need these days. You've been going straight for how long now? But I do now have to rethink a couple of things. Okay, Honors Day is that day. Exams start. Classes first week of May. Okay. If we had test 2, that's marked again. Oops. Okay. So if we had test 2, I'm thinking just depending on the material we get through in the next couple of weeks, and I'll make sure everyone has plenty of advance notice. I'm favoring either Friday the 16th or Friday the 23rd of April. That gives us another couple of weeks worth of learning that we can have one nice test over and then a full week of review and coalescing of facts before exams.
You said the 16th or the 27th?
Yes, those are the dates I'm favoring as of this, as of right now. Any questions about scheduling, calendar, planning, etc.? Okay. So, and I will remind people of this as we go. But right now, this week, we operate as per normal for this particular class. Now, how are you guys feeling about assignment 5? 18. Yes. That's it. 18. You're in cuboid in number 17. Just roll smart. Okay, I realize what happened now. I didn't do the volume, the density of water. I apologize. I should have listed that. Okay, volume. Ooh. You know what happened? I put a note in my phone to tell you to not worry about number 18. And I either didn't tell you,
You
or
said 8?
18.
I think the email said don't do 8.
Don't you 8?
No. Maybe just grab a
Oh, whoops.
Yeah.
Okay. Yeah, I didn't say anything about 18. I would like to talk about it quickly. You know, let's work this one together. I think this is a good question. It's just kind of weird. So number 17, actually, I suppose we'll do number 17 very quickly, gave us it's not strictly speaking a cube, but it is, I suppose, scientifically speaking, a box of known dimensions. This is not going to be to scale. 3, 13, and 56. You were asked to find the volume and the surface area. And I gave you a list of various formulas for that. Quick review though, the surface area of a 6-sided regular cuboid like this would be the sum of the areas of each individual flat face. But what we need for number 18 is the volume. So the volume of any given shape is its length times its width times its height. So you're just going to take these 3 numbers, multiply them together, and get one really big number with units of meters cubed. What sort of numbers do you guys got for that? Because I don't have that off the top of my head.
I got 16, 7, 4, 4.
Okay. And since we multiply meters times meters times meters, that would be in units of meters cubed. This thing is big. I'm going to double check that real quick. If I can find where tiny went. Come on, tiny. There it is. Of all the things I carry in my backpack, my answer key to this assignment apparently isn't one of them. All right, very good. So that is the volume of this particular object. That represents how much physical space in the universe it takes up. The cube has this much volume now. And we are going to submerge that cube in water. Or at least, we're going to submerge some of it in water. Let's suppose there's a blue one. The oceans are purple today. This is still a cube, but I'm drawing it flat right now because we need to look at it straight on from one side for this part to make sense. And we are going to submerge it in water. We'll just assume that it's floating. And And when you submerge anything in a fluid, which includes water, so when you put something into water, have you ever noticed, say you have the sink filled and you put something into the water in the sink, the water level of the sink rises. It's not that there's more water in the sink, it's just that the object is now taking up space the water used to be in and has displaced that water. So if the whole cube was submerged, it would displace this volume of water. This space of water would now have to go somewhere else, and it would drive up the water level appropriately. The problem doesn't say that the whole cube is submerged, though. It says that approximately 1.2 meters of it is sticking out above the water's surface. Come to think of it, the question doesn't specify which dimension of the cube is its height.
That's what I was wondering.
That's unfortunate.
But isn't that the same for 117?
Yes, it is the same cuboid from number 17. Number 17 just doesn't specify which of those three numbers is the height of the cube.
I think the two biggest would be like what the size of a rectangular cube would be.
Yeah.
And the shortest.
I suppose, yeah, if it's okay, it's a good thing we're doing this one together because there's a lot of assumptions. I'm going to tell you the assumptions that I would make so that you then have them and can write down the answer. If this is a rectangular box, I suppose the assumption would be that its shortest side is its height. It's like when you get a laptop, when you buy a new laptop and the box is sitting flat out like this and its height is its shortest dimension. If we make that assumption, that would mean that the 13 meters is the height of the box, which means that about 11.8 of those meters are under the water. Which means, since we're asked the volume of water displaced, we care about how much of the box is under the water. So we would have to redo our volume equation, but we would, instead of putting in 13, put in the 11.8 that is submerged. And that will tell us a slightly reduced amount of volume that is under the water level. What kind of figures we got? Keeping in mind that this half of the assignment isn't sig fig math.
18,198.
Very good. Since we didn't specify sig figs, I'm just going to write down the whole thing. The units would still be meters cubed because we are solving for volume. And so that is the amount that is under the water. That's the amount of water that would be displaced. So that is all that is needed for 18. For 19, this is related, so I'd like to do it too. It tells you that the density of water is 1,000 kilograms per meters cubed. Quick straw poll, how many of you guys are either going to major in chemistry or some field that needs a whole lot of chemistry? Okay. I assume then you're probably accustomed to dealing with the density of water, but I know that there's kind of a unit disparity. Chemistry likes to use smaller units than we use down here, because when we use like grams and liters for everything, the numbers just get huge. So this is one of the more commonly used units of water density in physics. We do it, at least we do it sometimes in kilograms per meter cubed. because we really like kilograms for mass, and because meters are bigger, so that kind of makes our answers smaller. So using this density, and thankfully our volume is already in units of meters cubed, we are asked the mass of water that was displaced by the box. So we know density of water, we know volume of water, solve for the mass of the water. And this type of math will become important when talking about buoyancy, which is the science term for floating. When any one object floats in any fluid, you have to displace some volume of that fluid by being submerged in it, and the mass of the floating object is equal to the mass of the displaced fluid. So when we find this mass of displaced water, that should tell us that the box should have the same mass if it's floating like that. Okay? I'm having a much harder time reading facial expressions these days. It's just a byproduct of it's fine. It just is interesting trying to interpret all the eyes. A lot more faces more concerned than I would normally read. So really quickly, density is defined as mass over volume. So if we treat this like a formula, we have density equals mass over the volume we just calculated. And so this is going to be a really big number. So our mass is going to be a frighteningly large amount of kilograms. $15 million. What is this thing made of? It's also huge. That played into it. For scale, its longest side, I think its longest side was 56 meters. That's about 185 feet, which in football terms is 62 yards. So this thing sitting on a football field would take up most of it. So we're floating a football field right now. Makes sense it would have a large mass. So kind of a ridiculous physical situation, but good numbers. Any questions?
Wait, so you said don't worry about number 8?
Do not worry about number, well,
It's the truth.
I did announce you don't have to worry about number 8. After thinking more about it, it's a little clearer than I originally noticed it being. But I did say you don't have to worry about it, so we won't.
Isn't that what we use for 10 to see if it, our equation was right?
Okay, so number 10, use the tension equation. What do you feel the tension to be? Measure it to be. Oh yeah, 10 also uses percent error.
Either way you do it.
Yes.
I thought number 10 was just comparing things we got with what was on the first.
Correct. And when physics asks you to compare two things, that usually means percent error or percent difference. Granted though, because 10 is vague and doesn't say that outright, I'm probably going to be very lenient in the answers that you put. Because it doesn't say do percent error.
Well, you guys did the truth test, so I can never remember which one goes into what. Like, for the truth, like in my mind, I guess like you test it, like that's true, but then it's like number that they give you. You know what I mean? Like,
Yeah, part of that is to do with just how an any given professor writes writes the formula out, because you could say tested, you could say predicted, you could say calculated. For truth, you could say actual or measured, or just depending on the words used.
Truth is the one that you find, and then
Yes.
the test is the one that they give you.
Yes.
See, I always
The
get-
truth is supposed to be the actual physical thing, which means the truth is supposed to be what you're measuring, like what you actually take a meter stick to and physically measure on physical ground. The test, because the test, this is the vernacular that's used by Dr. Rodekor, who taught me, and also who originally created this class. Test refers to what you estimated. So if I was to write down the percent error formula, I would probably do calculated minus measured divided by measured.
So in terms of number 10, like for the number that we found for 9 would be the truth, and then the number that's number 10 would be the test? Or is it not?
No, that's reversed.
No.
When you use a formula to calculate something, that is your best guess. That is the estimate, that is the calculation, that is the value you will be testing.
Okay.
The censor is doing its best to represent the truth and reality to you. So the .451 given to you in number 10 is the truth, is the measured physical reality as represented by the tool, and what you estimated yourself is the thing that you're testing.
Okay.
Just making notes for later. Okay. I apologize for the confusion there. In future documents, I'm planning on rewriting that formula as measured minus estimated divided by measured. If that is more clear to you guys. And I will also be rewriting the question itself, so it's a little more clear. Any other questions for this particular assignment? 13. Ah, yes. Our good old friend, not quite triangle. So the section of the assignment that contains 11, 12, and 13 asks you to find the area and perimeter of all of these particular objects. And in 13, you are given an object where the long side is 25 feet. That's this top one. The bottom right side is 18 feet. And the rightmost angle is 23.2 degrees. Now, what you've been asked to find is the area and the perimeter. And the perimeter is just the sum of all three sides added together. So in order to find perimeter, we need to find the length of that particular side. And I can't think of a much quicker way to do that than simply. borrow our tactic from when we're doing these types of questions before. We want to use trig to find first this side. I call that side B, the imaginary line that we just drew in. And since we know the angle and the hypotenuse of this rightmost triangle, we can use those to figure out this imaginary little line that we drew, but also figure out how much of that 25 feet belongs to the right triangle. Once we have that number, and we'll do this together, I'm just setting it up. Once we have that particular number, we would then have on the left triangle, B is the same leg, so that number is now here. And this piece would be 25 minus A. Whatever we found for A, that leg would be 25 minus A. Because we know the full length of that full side of the whole triangle, and now we know how much goes to which of the two triangles. Once we have those two sides, we can use Pythagorean theorem to find the other side. So, I'm sorry, I'm pointlessly looking around for a marker cap that I don't really need, but I prefer having it. Anyway. So, looking at just the rightmost triangle for a second. We know the hypotenuse and one of the angles. We can use that to figure out what the other two sides are. From this angle's perspective, I'd say side B is the opposite leg. So sine of 23.2 is equal to side B over 18. And side A would be the adjacent. Cosine of 23.2 equals A over 18 feet. Kinds of values should you guys get these two? Very good. Excellent. So, now know what B is, which is convenient because that's going to be constant across the entire shape. Now that we know A, we can figure out the side of, we have two legs of the leftmost triangle. Green. There's that cap. We don't actually know any angles here except the right one, but we do now know this leg, and we know 25 minus 16.54. It's going to give us 8 points. $8.45555. Sorry, actually that's a misnomer. 5 doesn't repeat it, so let's round it off. Now all we really care about is this last side. So we're okay not knowing any of the other angles. All we really need is that side. Pythagorean theorem. We should be able to find that one pretty handily. Once we have the length of that side, add it to the others. That gives you the perimeter. And that's surprising amount of work just to find the one perimeter. The good news is, we already have, excuse me, we now have everything we need to find area very quickly. Find where my right space tab is. There it is. Okay, so this is the table of geometric formulas that I gave you for volume, area, surface area, perimeter, etc. And one of our formulas is one perimeter for a normal not right triangle, but two, we also have a short and concise way to find the area of such a triangle. We have what this triangle. So from this perspective, we do the long side times this height, a little imaginary number that we found that is part of the two divided triangles, and multiply those together, divide by 2. So I know I've relabeled things a couple of different. The letters used to denote sides are not the same across these two things. A equals B times H over 2. The B side is the physically longest side of the triangle. That's our 25 feet. And the H term is the distance from that side to the opposite vertex, which we have found to be 7.09. And then all that divided by 2. So that's probably one of the problems that requires the most just writing work on this particular assignment. That's what I said. 16. Okay. How you guys feeling? Yes.
Could we do 15 and 16 and like draw out the physical objects of them for like visual?
Sure. And let's see, we've got a cylindrical glass of water and a water droplet, which I instructed you to treat as a sphere, because there's not an easy formula for volume of a teardrop. Okay, so I used to have like 3 erasers. There's currently 1. Where do they go? Where do they come from and where do they go? Okay, so our 2 physical shapes from 15 and 16 are a cylindrical glass of water, and I know probably most beverage glasses aren't perfect linear cylinders, but for the sake of simplicity, let's assume this one is. And a cylinder has a height, this particular cylinder, has a height from top to bottom, call that H, equaling 7 inches, and a diameter of 2.75 inches. The next one, we're given a water droplet, which I have instructed you to treat as a perfect sphere with a diameter of 0.35 centimeters. And spheres don't really have dimensions beyond its diameter. It has its radius, but that comes from the diameter. So, these are the two shapes that we haven't already covered earlier today. And on this particular formula sheet, excuse me, I forgot to speak English for a second. We have formulas for the surface area and volume of both a regular cylinder and a perfect sphere. The cylinder is the trickier one because, I'm sorry, I'm going to have to pull this away for a second because it's too pixelated on the screen. Okay. Now a cylinder, finding its volume is pretty straightforward. Height times radius squared times pi. The main thing to remember is that radius is half of the diameter. So what you would actually plug into the formula is pi times the diameter divided by 2 squared times the height. So make sure to cut the diameter in half first. The surface area is a little bit trickier. With a box, you would take the area of each single side and add those together. And you do still do that. It's just a cylinder has 3 sides, all of which are not, I guess, not exactly normal shapes. We have the circular top, the circular bottom, and the actual wall of the cylinder itself, which technically speaking, if this was a soda can, you could cut the top off, cut the bottom off, cut a line up the side, and unfold it into a flat rectangle. So it is a flat rectangular piece of material, but you do have to sort of work your way there from the circular ends. The 4 things listed right here, I know it's a little hard to see from a distance and on the screen. This is surface area of the top circle, surface area of the bottom circle. It's the same formula because assuming that it's a straight linear can, it's the 2 circles are going to be identical. So these both say pi r squared, just the area of the circle. The third formula is the area of the side, which is the entire surface of the entire side of the can, and that is listed as 2 pi RH, all being multiplied together. The thing listed at the bottom is area total. And it is literally just the previous 3 formulas added together. It is the one formula that is the entire volume of this shape, the entire surface area of this one shape. So that is listed as 2 times pi r squared plus 2 pi r h. Round shapes tend to have these slightly more complicated formulas, in my opinion. So this is all 3 of the sides added together. We have the actual flat side of the can, and this is the 2 circular parts added together. And plug everything in, press enter, and that should give you the total area of the entire object. Remember though, radius is half the diameter. For the sphere, well, I'm going to relabel this. That's the way it is. For the sphere, the formulas themselves, well, they're probably as complicated, maybe shorter. For the surface area of a sphere, we have pi r squared. Sorry, 4 times pi times r squared. Remember again, radius is half the diameter, so take half of 0.35. And then the volume of a sphere, this one's slightly funky, 4 over 3 times pi times r cubed. How do you guys feel about using these formulas? Okay. We're nearing the end, and I am comfortable saying that I will collect this from you on Friday, because I don't, it doesn't feel right to take it first thing coming if there's not seeing you for a week. So if you feel like you're done with your assignment, I will go ahead, you can go ahead and leave it with me, but my official due date is, I will collect this assignment from you on Friday, excuse me. I'll collect this from you on Friday, and since we're pretty much at the end of lecture, that is when we will begin the homework 6 materials. To go ahead and let you know what those are going to entail, these ones will involve not necessarily using a graphing. There's going to be graphs. They will not be produced on a graphing calculator, since not everyone owns one. This will be more about interpreting lines on a page and how we can what those physically mean in terms of spatial physics. We're going to be interpreting graphs for physics meaning, graphs and the lines on those graphs, in addition to starting to work on some vectors and some 2D physics. So we'll be getting, everything up to this point has been a lot of review, geometry, trigonometry, how to do algebra, review for getting into what you're going to start Physics 1500 on. This next assignment is the start of Physics 1500. So getting you a leg up on the first material you'll be seeing in there. And if you take it next semester, it'll be with me. So I'll be the one, there'll be a more smooth translation, no change in teachers. And that's kind of one of the reasons this class exists. It's A, to warm you up, and B, to get you more to know who's on the physics department who you're going to be working with.
So Dr. Rose
I don't think Dr. Odecourt is teaching 1500. There is no guarantee on 1510. Because things get shuffled around semester to semester basics. But I believe the current schedule has me listed as 1500, and I prefer it that way, so that you guys don't have to meet entirely in person.
If we're taking, because I am taking physics over the summer.
Ah, okay.
What is the situation with that?
I don't actually know who's taking physics over the summer. Are you already registered for it?
No, but
Oh,
I'm going to have to with my schedule.
okay. I don't know exactly. In terms of physics, I don't know what's being offered in Haiku over the summer. Sorry to say. In that case, I am not teaching this summer because I'm getting married. Thank you very much. I'm taking the summer off to adjust to married life and take care of the house while my fiance is working in nursing school. Well, fiance now, like that. So let me know if you have any questions wrapping this particular assignment up over the next couple of days. But we will officially collect this on Friday, where we will officially begin looking at some spatial physics together. Yay. I will go ahead and take it if you are absolutely Please have a wonderful day.